Hi guys, this is the video for chapter 10, lesson 6. In this video, we're gonna continue to take a look at circles. The big topic we're gonna be looking at today is called secants, tangents, and angle measures, okay? So last class we talked about tangents. They were basically a line that intercepted at the circle on the circumference at one point. A new line that we're going to take a look at today is called a secant. And so it's different from a chord because it is actually a line. It's not just a chord. A chord would be within the circle, and so a line or a secant goes through the circle. And so a secant is a line that intersects a circle at 2 points. Line that intersects a circle at 2 points. So we're going to take a look at some angle measurements that we notice when there are secants and tangents, okay? So this is a secant here, right? 2 points, and this is a secant here. That's 2 points right there. So I would definitely put this down in your notes, but there's two big ideas that we're going to look at when it comes to secants and tangents on a circle. And so I'm going to just split my page to two parts, and I'm going to have two pictures where I draw them out. So the first one is where you have two secants intersecting, okay? So they might intersect not at the center of the circle. They could intersect anywhere as long as those lines cross, right? And so I'm going to give this an angle and call this angle 1, angle 2. And I'm going to give these intersection points some names, A, B, C, D. So there's two secants and they're intersecting. And of course, they both cross the circle at 2 points. So here's the big idea. If you have two secants or chords, because a chord is really just the part of the secant that's inside the circle. If you have two secants or chords that intersect in the interior of a circle, so they intersect inside the circle, then the measure of an angle that's formed, so here's like angle 1, angle 2, we could say angle 3, angle 4, right? These angles are formed by their intersection. The measure of the angle that's formed is actually half the sum of the arcs intercepted by the angle and its vertical angle. Okay, so that's a mouthful. So basically what that's saying is angle 1 would be half of both of these arcs added and divided by 2. So in some way, kind of like the average. So angle 1 would equal 1/2 of arc AB plus arc DC. Okay, so it's kind of like the average of those arc angles. Okay, so let's talk about what angle 2 would be, right? Angle 2 would be the average of the arc that we call it intercepted by the angle and its vertical angle. So this is the angle that's intercepted by this angle. So you can see it kind of corresponds angle 2 and then the arc angle here. And then the vertical angle, so the opposite angle, the opposite arc angle here. And so angle 2 would be 1/2 of basically the average of the arcs, BC and AD, okay? So that's just one big idea here, and we're gonna have to find that in a second. The next thing I'm gonna talk about is when you have a secant and a tangent that intersect. So remember, a tangent just crosses the circle at 1 point. So it's just barely touching right here at 1 point. And then we've got a secant. So let's say I've got, my secant here. And I'm not gonna, I could keep going through, that would be a secant line. But I'm just gonna have it stop and intersect right where that tangent point of tangency is. Maybe I'll just move this over here so it kind of, looks different. So it doesn't look like a 90-degree angle. But let me label some of these parts. So I'm going to call this angle 1. This is angle 2. Point of tangency is A. This intersection point is B. And I'm going to give this point C right here, okay? So if a secant and a tangent intersect at the point of tangency, just like this picture shows, then the measure of each angle formed is 1/2 its intercepted arc. So what that is saying is, looking at angle 1 here, this angle 1 is 1/2 of the arc that kind of belongs with that angle. So that intercepted arc would be arc BA or arc AB. 1/2 of arc AB. And then using that same idea, angle 2 would be 1/2 of the intercepted arc, which is right here. And so that is arc A, C, B. And see how I put that third point right here? So I can label it, because if I just labeled it AB, it would be the same name as what's over here, and that would be confusing. So 1/2 of arc ACB. So let's take a look. Let's use these ideas and bring them to some of our problems. Okay, so really all we're doing is just working out and solving for the angle measurements. Okay, so this angle 1 is the average of those intercepted arcs. So it'd be 1/2 of 52 plus 40. And then add them up, you've got 92. Half of 92 is 46. So angle 1 equals 46 degrees. Okay. Arc GH. Okay, so this time you're given the angle and you're missing the arc angle. So let's use the same idea. We know that 45 degrees would have to equal to 1/2 of 28 plus something. I don't know what it is, plus GH basically. So I'm basically using the same idea. The angle equals 1/2 of the arc plus the arc, right? So I'm going to work backwards. I'm going to multiply by 2 on both sides. So 45 times 2 is 90. And then I have 28 plus 8x minus 28 on both sides. And the answer is 62. Okay, so when in doubt, use the template equation and plug in what you know. Looking at angle 3. So that is 1/2 of the intercepted arc, which is 220. So 1/2 times 220 equals angle 3. So angle 3 is just 110, right? Okay, if you want to pause and work out these next few ones, you are more than welcome to. So number 4, arc RT. Well, we know that angle 74 degrees, right, is equal to 1/2 of arc RT. So if I want to find arc RT, we can just double that. So 74 times 2 is 148. Okay, looking for angle 5. So this time we have these intercepted arcs, which means the angle that I would find is right here, and that is not angle 5. However, I know that W and angle 5 are supplementary, so I can also use that to my advantage. But let's find W first. So angle W equals 1/2 of 30 plus 90, which ends up being half of 120, which is 60 degrees. Okay. But I want to find angle 5. So to find angle 5, it would be 180 minus 60. Oh, this is a 130. Okay, so typo here. 130. So 130 plus, let's work this out again. So, ooh, so this is actually a 130. So angle W equals 130 plus 90, which is 220. Okay, and so angle W equals, well, we gotta do 1/2 of that. So 1/2 of 220, and so that's 110. And so to find angle 5, 180 minus angle W equals angle 5, because those are supplementary. So 180 minus 110 is 70 degrees. Angle 5 is 70 degrees. Okay, last one. So again, we don't have the exact information they're asking us to use really, so we kind of have to work our way around and puzzle piece it. Well, if we know that this is 160, a full circle is 360, right? So if this is 160, this would have to be 200. And then we know that angle 6 is just half of its intercepted arc, which is half of 200. And so angle 6 would be 100 degrees. Okay, so there you go. Okay, the next thing we're going to take a look at are intersections outside a circle. So I would definitely write some of these notes down as well. And what we have here, I'm going to draw 3 circles. 1, 2, 3. And we're going to have some secants and tangents that intersect outside the circle. So first I'm going to have 2 secants that intersect outside the circle. And then I'm going to have a secant and a tangent intersect. And then I'm going to have 2 tangents intersect. And I know this doesn't look quite like, let's see. That's a little bit better, right? 2 tangents, so they just intersect at one point. Okay, so let's talk about what's going on. Let me label this. So let's say the point of intersection for all of them is called A, the point where they intersect. And then B, C, D, E, B, C, D, B, C, I'm going to give this a point D, okay? So let's talk about what these are. This is where we have 2 secants intersecting. This one is where we have a secant tangent intersecting. And this is where we have 2 tangents intersecting. So the truth that we see when we see 2 secants intersecting, the measure of the angle formed by the intersection. So speaking of angle A, that's what we're talking about looking at today. Looking at the angle that's formed by where they intersect is always going to be 1/2 the difference of the measures of the intercepted arc, okay? So 1/2 the difference of the measures of the intercepted arc. So what that's saying is angle A is always going to be it's always going to be the difference between the arcs that are created. So the intercepted arcs, we have your big arc, big arc, big arc in red. And then you have your little arc, little arc, little arc in orange. Those are called the intercepted arcs. So angle A is 1/2 of the difference of the big arc minus the little arc, BC. Angle A is the difference of, is 1/2 the difference of the big arc minus the little arc. Angle A is 1/2 the difference of, you guessed it, the big arc. So I'm going to name this BDC because it's a big arc, minus the little arc. And that's the pattern. If you know this to be true, you will remember how to work these out whenever you have an intersection outside a circle and you're looking for that angle, okay? The idea is the same, but the information given to you might look a little bit different. So let's take a look at our study guide and work some of these out. So they've got an example problem and they've got the 3 types of intersections here. And let's work some of these out. So looking for angle 1, big arc, 1/2 of big arc minus little arc. So 1/2 of 80 minus 40, which is 1/2 of 40. So angle 1 equals 20 degrees. Nice. Number 2, angle 2 is 1/2 of 160 minus 80. That means 1/2 of 80. Angle 2 is 40 degrees. Okay. Okay, looking here, I only have the big arc of 220. I don't have this little arc. However, I know that this little arc is 360 minus 220. So 360 minus 220 is 140, right? And so I'm going to work this out. Angle 3 equals 1/2 of 220 minus 140. When you subtract them and then divide by 2, that is 80 divided by 2, or 1/2 of 80, is 40 degrees. Okay, looking here. All right, they've given you the angle. They're asking you to find the little arc. So using the same idea, angle R, which is 20 degrees, is equal to 1/2 times 70 minus X. I don't know what that is, JP, arc JP. So to work backwards, because this is dividing by 2, I'm going to multiply by 2 on both sides. So I have 40 equals 70 minus X. And then I'm going to minus 70 on both sides. Now, I've got a negative, but be careful because here I have a negative X. So divided by -1 on both sides, X equals 30. And arc JP equals 30 degrees. Okay. Number 5. Tricky here. We don't have any of the arc angles. So let me just fill out my template. Angle 5 equals 1/2 times, okay, so I have X minus 360 minus X. Okay, I'm going to do it like that because if I label this big angle as X, oh, no, this little angle. Okay, this little angle is X. Let's give it a variable. So I'm going to take this off here. So let's say that this little angle is X. And this would be 360 minus X. Okay, because the relationship of the two are like that. So I'm going to say angle 50 degrees equals 1/2 of 360 minus X minus X. Okay, so thankfully I had the same variable, so I think I can find out what X is and then use that to help me find ln. So First of all, I'm going to multiply by 2 on both sides. 100 equals 360 minus, and I'm going to say 2x, okay? So now I'm going to add 360 to, or subtract 360 from both sides. Subtract 360. And so I have 260. Negative 260 equals negative 2x. So divide by negative 2 on both sides. And when you divide this, you have a positive 130 equals x. And so that is actually ln, because if we labeled this as x, ln, arc ln, excuse me, equals 130 degrees. Okay, last one. So let's use what we know of a full circle to find, excuse me again, I have allergies. Find this little arc NP. So this full circle would be 360. So 360 minus 100 minus 80 minus 110. And you're left with 70 degrees. Okay, so now we can work this out. Angle V equals 1/2 100 minus 70. And so you have 1/2 of 30 degrees, which is 15. So angle V is 15. All right, and that's it. So hopefully that made sense. And if you understand the big concept here, that concept transfers over to all the circles, and you can use that for any intersections where an angle is created outside the circle.